How's it going, everyone? Today I am going to make a popsicle stick bracket using OpenSCAD. OpenSCAD is a programming CAD tool. So you write code and it turns into 3D geometry. And then we will try printing one out. So I've got some popsicle sticks for my kids to play with. And what I want to do is just make a little bracket so I can join them together really easily. And they're 2 mils thick and 10 mils wide, so they're pretty easy to play around with. Should be fun. Actually, I was inspired because my daughter did like a bridge building challenge at school, and it was she was learning about building bridges. And I thought, it's a good opportunity to do some 3D printing. So, NVIDIA and your crazy flickering GPU drivers. Hold on, let me just try toggling VSync. Maybe that's working. I don't know. We'll find out soon enough, I guess. Right, so what I want to do is I want to make one kind of clip part, and then I want to rotate it around and make multiple and have them sort of join in the middle with a cylinder of some sort. So let's make a cylinder to start with. And the height's going to be 10 mils, and the diameter, let's just make it maybe 3 is okay to start with. And the resolution is a little bit low, so one of these will make it better. And then what we want is we just want a little piece sticking out the side. So let's make a cube. And we want to make that 10 millimeters long. Maybe 3 is enough. Might need to make it a little bit thicker. And 10, that should be enough. And so this is going to be, we're going to chop out a chunk from the middle of that. So we want to take the difference of that cube and a cube, actually that's, yeah. So that the stick is actually 2 mils thick. So maybe we need that to be 4 and that to be 4. 1 mil is not really thick enough for 3D printing to build, but I guess it depends on the material. Yeah, I'd probably go with maybe a little bit thicker, but we'll try it and we'll see how it turns out. Now, the interesting thing about this is also we don't want to take just the difference of that. We also want to include the cylinder in that. And then finally, we need to translate this down a little bit. So negative, we want to move it down. It's 4, maybe -2, is that right? Yeah. And this one, we want it to be in the middle. We could actually do it a little bit differently, but this is fine. We want to make that down 1 mil. Yeah, actually what we want is we might make a submodule to deal with that stuff, but that's okay. So putting a hash in front of it shows it up in red so we can see what's going on. Now the other thing is we can't have all of them joining right at the origin. We will need to offset them by a small amount, and rather than working out the mass, I'm just going to offset them by 1 millimeter. So let's just put a constant at the top here. The width is 10 and the offset is 1. So width. And in this coordinate system, we want to increase x by the offset. So it's a little bit longer. So now that's 11 mils. And actually, that one, we can just do that. I think that's probably the best. So that means that our stick will fit all the way in. And actually, if we rotate that more, it's still going to be a problem. We may need to increase the offset more as we add rotations. Okay, right. So what I like in OpenSCAD is you can make little modules that do stuff like that will iterate over your geometry. So let's make okay, so let's make a module called rotations, and we're going to go for x equals 0, and we want to do 60 to 360. Rotate around the z-axis by, let's just call it A because it's actually an angle, and then let's execute the children. Execute the children, yeah. Programmers say lots of stupid stuff. So what we want to do is we want to take that and we want to go rotations, right? So we get that, and then we also want to do that there, so we get that. So this looks okay, except that piece, that little gap there is really narrow. So maybe we just need to do something like that. And maybe let's just make it 5 for good measure. Now, is that good enough? One thing I did want to play around with was putting a piece right through the middle, so you could have the ability to put a popsicle stick going outwards. But these gaps here are actually sufficient. It's 10 mils wide, but this is also 10 mils long, so you could put a popsicle stick coming out like this way just fine. It may not be as strong, but you know, it's bridge building, so who cares? It's not that critical. Okay, so what I want to play around with now is firstly, it doesn't really look like we need that cylinder. I want to capture that as a parameter as well. So now we could just increase that a little bit, and we can probably reduce that. That is probably good enough to 3D print. 2 mils is a pretty reasonable thickness for strength, and I guess especially in this case it doesn't really matter. What I do want is to make this parametric, just because I would like to limit this so I can print out some extra bits like this. So maybe we can try printing this one. I think that's like a really good start for building bridges because you have both the horizontals and the bits to build triangles. So let's just go ahead and try printing out that. Again, like the cylinder is not really necessary, so I'm just going to get rid of that actually. Right, so over here we're going to come here and render that, which basically builds the geometry as opposed to the preview that we were seeing previously. You know what, it'd be kind of cool to put a hole in there so that I could stick skewers through as the laterals. Right, you know, that's actually not a silly idea. So let's take that cylinder, stick it there, and it's going to be like a lot smaller. That part's okay, but I guess it's like 2 mils. I should probably go and measure one. Hold on, let's go and grab a skewer. So I got a bunch of skewers, and I'm just going to measure them with my... I wish I had my calipers on me. They are 3 mils in diameter. So let's have a look and see if that's going to compromise. I think it should be okay. Yeah, it looks okay. For me, we can jam a skewer through there. The other thing about 3D printing is, well, OpenSCAD at least, I don't know about generally speaking, but when you make a hole, even though the distance from vertex to vertex is going to be 3 mils, the distance from like the midpoint of the edges will be slightly less. So this, even though it's set to 3 mils, it will be a slightly tight fit, which is actually okay. And I guess the other question is maybe that even though that's 2 mils, I just wonder, because like the tolerance on these popsicle sticks is not that good. I mean, what do you expect when you pay a few dollars for 100 of them? I just wonder if I should make it like sort of 1.8 or 1.9 mils, so you have to jam them in there. I guess we can do a trial print and see how, if it's loose. In theory, you can put a bit of tape on the end of the sticks to make them fit in better if they're loose. Alright, so let's render that again. That looks good to me. Let's export that as a STL. Build folder, bracket. Let's just pull up slicer. And we're going to add... The last thing I made was a tortilla press. It was awesome. Only the hinges, not the whole thing. It was called popsicle bracket. That looks pretty good to me. Very straightforward. I will send that G code to my printer. scheduling upload. Why does it schedule the upload? Print host upload queue. Oh, it says completed. Oh, yeah, it has. Great. Okay. Okay. Right. So for the first time ever, I'm live streaming a live stream. Nine minutes to print. That's awesome. I should have done this earlier. Set the oven to the cooking temperature. Okay, we'll have to wait a few minutes for it to warm up. In the meantime, let's make the other version. I guess one with 2 could be good. Okay, that's why we need a cylinder. Okay, and why is that doing that? I guess it's the maximum. Okay, so that will be good for like the end of the bridge. So we want that one. Render. Export as STL. And then I would also maybe... Do I need that one? Probably not. Probably those two is enough. So I find with my print bed, one of the biggest problems is the aluminium, even though it says it's got to temperature, it hasn't finished expanding. So thermally speaking, it's good to just, it depends on actually the ambient temperature quite a bit as well. But even though the bed is getting to sort of 60 degrees Celsius, it still hasn't fully settled in terms of its thermal expansion. And what that means is the first layer, if you just switch the printer on and try and print, the first layer will be a little bit thicker than it would be if you have already done like several prints and everything is kind of expanded and settled. But to be honest, with this little clip, it's not something I care about that much. So. Awesome, let me just, I wonder if I can full screen this. Can I? That might just be as good as it gets. Okay. Excellent, I'm going to go and point that a bit better. So the first layer looked okay, which is good. It's always a good sign. One of the other things I made a while ago, which is fun, that also has to do with popsicle sticks. Let me just show you. Thingiverse is an awesome website for finding stuff. Why is it not showing up? Oh, that's weird. Google found it right away. This is quite a fun one. It's a parametric mold for making Play-Doh popsicles. And I had fun doing this. The only thing that makes me sad is I wish I could use real food. Use it as a real mold, but I'm not completely confident that Chinese PLA is food safe, so I avoid doing that. Fun for kids though, and it's fun to make. One of the cool things about Octoprint is this G-code viewer. Here we go. So as it shows you the G-code instruction as it's being sent to the printer, and in theory I guess you can kind of see the whole object. This is not a very exciting object. Every layer is the same as the previous one. And you can also see this, which is the actual instructions being sent to the printer. Temperatures look good. Five minutes left. The other thing I wonder about is whether I could get away with making this thinner. Not thinner, sorry, less wide. Instead of 10 mils wide, could be 5 mils. It would still probably hold the popsicle sticks okay, but they'd print faster. Three minutes left. So I just heard the Y-step motor do something weird and now it's offset. Typical 3D printing error. So I'm going to cancel that print. But it's enough to check the prototype is working okay. It's actually been quite cold today and we have the heaters on inside. And I have pushed my stepper drivers right to their limit and I have a fan pointing at them. But if they overheat, they skip. And so, unfortunately, that sometimes happens. Not very often. So we'll bring that back to the home position. And we'll go and grab that part and have a look at it. So there's the part. It's got a bit of an issue, but we'll see if the tolerances are right, which is actually more important. So the hole for the skewer is possibly too small, which is kind of to be expected. Oh, but the fit for the sticks is quite okay. There's a little bit of it almost needs some like ratcheting barbs to hold it together, but you know, for a toy to build a bridge, I'm pretty happy with that. And once the inside is cleaned up a bit more, there's a bit of a lump in there which I'll clean out. I think it'll be okay. Like I think it'll be quite okay. So yeah, that's really it. Just wanted to demonstrate some OpenSCAD stuff. I like sharing that. When I first did OpenSCAD, someone else, one of my friends, demonstrated it for me, did some pair programming, and it's pretty cool because it's not often you get to see your programming in real time, and that's literally what's happening when you write code like this. I really enjoy it. I'll print out some more parts and I'll shove the code on GitHub if you want to make some for your kids or just to build a bridge yourself. You know, have some fun. It should be awesome. Excellent.